Hello guys, welcome to this session of solving LeetCode problem. Today we are tackling question number 47 called permutations number 2. I previously did permutation number 1. So if you are new to this series, this is your first video watching this series. This series is all about a realistic point of view of solving LeetCode questions by a software engineer. It is not a tutorial per se, but during the course of me solving the problem, I'll try as much as possible to explain my approach, my understanding of the problem, and its solutions. You're going to see a lot of errors, you're going to see a lot of mistakes, some are going to annoy you, but it's just part of the process. It is not a 2-minute video, a 5-minute video. It is going to be a lengthy one, mostly usually take about 30 minutes plus, sometimes typically about an hour plus. So stay tuned. But for this one, I'm not sure it should take more than an hour or even more than 45 minutes, because it is just a remake of this question which I already solved. So I've already seen this before, and for those of you who know, once you have solved something similar for algorithmic questions, it's easy to solve, to just tweak it a bit to meet the next variation of that question. So let's dive right in. It is weighted medium. It states, given a collection of norms that might contain duplicates, return all possible unique permutations in any order. You have examples 1, 1, 2, and you have 3 permutations. They are unique permutations, and same thing here. And you have the constraints where the length of the array is between 1 and 8, and the individual numbers themselves with elements themselves within that array range from -10 to 10. So again, we are going to try to generate all the, so our approach is trying to generate all the permutations, and in the course of adding each found permutation, we are going to check for duplicacy, right? If that permutation already exists in our result set, our result list, if it already exists, we are going to skip it. If it does not exist, then we are going to add it as a new permutation. So that's what we are going to do. So how are we? So the first thing is to generate a permutation, and what we want to do is, first of all, you have to understand that in order to calculate the permutation for each, the total number of permutation, right, for an element like this, mathematically, I think you have to do, so for each position, you are going to calculate the number of choices you have, right, and choices instead generate each permutation. So each choice is going to be in a sense that, so you have like, so in this case you have 1, 1, and 2, right? So in order to get the total permutation, you have to calculate each choice at each index, right? So at index 0, you're going to have 3 choices, right? 3. So we're going to have, this one is not yet fixed. So at index, you're going to have any element can take index 0, any element can take index 1, any element can take index 2, right? And at index 1, you're going to have only 2 choices, because the element at 0 is already fixed and these ones are not yet fixed, and that's the idea we're going to use. And so you're going to have, for a 3 by 3 permutation, for a 3 element, the total permutation is going to be so it's going to be, for position 1 we're going to have 3 choices, position, then times how many choices at position 2, which is 2, times the number of choices at position 3, which is 1. So we're going to have a total of 6 permutations for this set, right? Now, these are unique permutations. So these are the total number of permutations you can get here, right? But because we have repeating values, some of those permutations, in this case, about half of those permutations, will be similar, will be identical, it will be the same thing, right? The same numbers, the same integers in the same positions. So we can, if you take into consideration screening for identical permutations and only adding 1 to the result set, you're going to have 3, right? And so same thing if you have like a 4 by 4, right? If you have 1, 2, 3, 4, right? So for the first section, we're going to have 4 choices times 3 choices, right? That's for the second set. For the index at 1 times, at index at 2, we're going to have two choices, right? Times 1, right? So we're going to have 4 times 3, which is 12, times 2, 24, so it equals to 24, right? And it will factor for the number of permutation. So for example, if you see this one, we have 1, 2, 3, 4, 5, 6, right? So exactly, because they are not repeating values. But so that's why we have 6 permutations here. But if we factor for repeating values within the same element, you're going to have repeating permutations, and so this value, the unique permutations, are going to be less than. So how are we going to solve the permutations? The idea, I think, is we're going to iterate this. We're going to use a recursive algorithm, which is going to which essentially, so we're going to do private I don't know if this will be like void private int. It doesn't return anything, right? Private void. Anyway, we can change it whenever we want, right? Private void find permutation, right? And this is going to take our initial num, right, int our array, right? It's going to take an array, right, which is it's going to be, it can be a shuffled version of the initial array. It can also be the original array, right? This is going to take an index, right, which will be the index, let's say, from which we want to calculate the remaining choices. So for example, at index 1, we want to calculate the remaining choices there. At index 2, we want to calculate the remaining choices there, and so on, right? And the last part is going to take the result, right? And this is going to be a list of, I think, list of integer. Okay. Yeah. And so, okay. And yeah, so that's what that is going to be. Okay. No, I can also just take like the length. I can also take like the integer of the length of the array. Right. So yeah, we can go int right. So we can just go. So we can first of all compute the length here. Int length equals to nums dot length, right? And then we're also going to have like we're going to initialize the result because we're going to pass it in that array. Right, result equals to new array list, right? And then we're going to call this function, which will be nums. So we're going to put like nums there, and this will be like the index. So in the index, the first one we want to start at 0. Yeah, so the index is going to be 0. Yeah. As you can see, I'm not doing so much of a calculation because I have already seen this before. So, but it's going to make sense at the end, hopefully. And for results, we simply want to pass an result here, which will be an empty array. Yeah. And then the length, I'm going to pass the length there, right? And what's going to happen, and then right down, we're just going to return the result, right? Return. Yeah. And right here, what we want to do, the first thing is, you see, for the first time, remember we can have a single array with one element, right? I want to find the permutation. The permutation is just one. Okay, the number of permutation is just one for that. All right, so we want to check that particular variable, which coincidentally lines up to how we are going to save variable, because what we want to do is we want to continuously swap these values until we get to the last end of that particular array, right? And then we'll backtrack and continue. So we'll like swap, like, so we'll swap the first one, swap the second, then come back, we'll swap the first one, right? And then send it in the recursive array, which is going to take this one and swap it again and send it, right? And then at the end here, you're going to have a final set, which for the first time is going to be this array, the array intact. And then we are going to backtrack within each recursive loop, right? So when we backtrack, it's going to be the same array, but now the index is going to be 1 year, which now allows us to swap this one and this one, right? And then we're going to find another permutation, and then we'll backtrack, right? And then come out from that, and then go to the previous recursive loop, and then do another iteration. And in this case, let's just go for int I equals to 0, I less than then I plus plus. Okay, right. So right up here, what I was supposed to do, let's just add the comment there. Check if we have reached the end, which marks a new permutation found, right? Right. Which this particular is if I think it's index, right? If the index is equal to the length, and remember the length is never going to change, the length will continuously be the same, so no need to calculate it in here again. What is going to happen is we're going to add, okay, I'm going to do result dot add, okay, and we have to add this num, right? And oh, there is also something, so we cannot add this num for like this, because we're adding to this list, and this list requires a list of integers. In order to convert this list of integers, we need another helper function, which is private list of integer, right? And to list, which is going to take an int array called nums, right? And essentially we are going to do let's say list of integer array equals to new array. So in we are creating a new list. That's what we are doing. So we can like create a new list of array list, and then what we want to do is iterate through all of these and add them individually. So we're going to do for, and we're going to do a much more compressed for loop, which is int norms, right? We want to do integer array dot add num, right? And we simply just want to return integer array, right? So this way we can do two lists, and we can save the norms, right? And we can do that, but we also will, you know what, we'll leave it and I'll come and show you what, because essentially I'm just repeating what I did here the last time, because this one I solved it on my own, but there is a tweak I have to do here. All right, so I have to add another condition here, but you see why I'll have to add the other condition here later, right? So you see at the end, and this will make sense why, because the solution I'm writing now solve this problem and the other problem, but this one requires just a particular condition here. So add a condition for unique permutation, right? Like a 2-2, only this 2-2. Yeah. So, all right. So we are going to iterate. So we have that, right? And we're going to iterate at. Right, so this is not equals to 0. This is equals to index, because, like I said, we are not starting back. We are starting from the index, and each index we are trying to look for the number of choices at that index that are left to be made, right? And that's the idea. So we're starting at that index, iterating length -1, length plus, and what we want to do is swap, right? Swap the I and the index, right? Swap the elements at I and element at index. There's going to, so for now these are going to be the same for the first time, and when we start backtracking they are going to switch and change, right? So in order for us to swap, we need to use a swapping algorithm, which for those of you who are doing swapping algorithm, usually you always have like a temporal variable, right? So just to hold it, so I'm going to have an int temp equals 2. So I'm just going to have an int temp here, and what this temporal variable is going to hold is going to be temp. It's going to hold the value at j, norms at index, I think, right? And then we're going to now take the value norms at j should be equal to, no, we're going to put norms at j. We're going to put norms at j, right? Just 1 minute, please. Right. Sorry for that. We're going to put norms at j, and then we're going to equate norms at j should be equals to norms index, right? And we're going to now put norms at index should be equals to temp, which holds the value of norms at j, right? And this will be, so we're going to conduct the swap here, swap perform swap, and then When we do that, right, we need to do two things. We need to, when we swap for the first time, we need to send it, right? We need to send it back to this recursive array. In other words, because when we come for the first time and it's going to swap index, we want to do the swapping for each position, right, till we get to the end. Then we start backtracking. So in order, before we start backtracking, here we do backtracking. Okay. And before we do the backtracking, which essentially is exactly the same thing, okay, just so you know, because if we do this twice, we arrive at exactly the same place, right? So if we swap these two and then we swap the same two, you arrive at the initial array. So that's what backtracking looks like. Here we need to perform the recursion till the last index, right? So what we have to do is call this method again on itself, right? And again, we're going to pass norms, right? We're going to pass the index here is going to be j plus 1, okay? Not j plus 1, oh, sorry. So I plus 1, sorry, that's j. Sorry about that, that's I, we're talking about I. That we're doing double index. Okay, yeah, we're doing recursion, not double loop. All right, so we have the I there. Okay, so it'll be I plus 1, and then we are going to do, we're going to pass in the result, right? The result that we generate. Oh, by the way, we are returning this, right? We're returning that, and then we're going to pass in the length, which is length, right? Remember, the length is never going to change. We're always working with the same fixed number of length. So rather than calculating every time, we should just save ourselves and just calculate it once and do the recursion with the length, stuff like that. And we do the for loop and we do the backtracking, and then we escape. Yes. Now, I think this should work. Right? So if we try that, norms, list of integer, two lists. Oh, oh yeah, so we return, sorry, we have to return this. Oh, so you see, this is why I told you. So you see, we are supposed to return. So it's not supposed to have a return here, but we're supposed to return here because we're supposed to find this and then return out the result, right? So that's what we're supposed to return. And if we run it, we should have something. Incompatible type boolean cannot be converted to the list of integer. Alright, so sorry. So do result.add and return result. Do we even have to return the result, right? Because result is already done. Okay, we are not returning anything. We don't have to return anything. Like I said, since we are just calling the idea, so we don't have to return anything. We don't have to call it. Okay. Now, don't worry. Don't worry. 1, 2, 3, 4. Right, so we are having some field issue here, and what's the problem? So let's look at it again. You get the length, if length is equals to that, then we do that. You have the temporary, the temp is equals to that. Temp equals to norms I equals to norms index j. Yeah, this is wrong because it's supposed to be this, at least this one is supposed to pass. Where am I going wrong? Yeah, so I don't know what's wrong. So what I think we can do, so because what I'm doing here is, you see, I am sending everything correctly, right? Right, so the index, let me see, the passing I equals to index, and what's the index? Index is 0. What does index implement? Requires, what does it represent? Represents the position from which we're fixed. And so pass the index here, pass all the information. We're checking the index equals to length, results. Yeah, oh, by the way, we need to return here. Yeah. Need to return here. We have the for loop where I equals to index, I less than length, I plus plus, temp is equals to norms. This swap is correct. They will send for permutation where we pass I equals to index. Oh, yeah, okay, say, yeah, so here we are supposed to pass index, right? Because we are passing the next position, right? The next position to compute, and that's what we are supposed to pass here, rather than the index, rather than the index of the what we're using to iterate, right? We're passing the index, which is represent the position. So the first time we're going to pass all of this, right? The second time we're going to pass it with this index here. So we are going to swap with respect to this index. The third time we're going to swap with respect to that index. Then we're going to backtrack, swap with respect to that index. Then we're going to backtrack again, swap with respect to that index, iterate with I, swap, and so on. That should fix things. Yeah, okay, yeah, so this is the answer that I wanted. Okay, as you see, for the second case we passed because they are unique values. Now for the first case we failed because we have repeated values, and you see they are not unique. We have more cases than they are, right? So you see all of these cases, they repeat themselves twice, and because of the repeated ones. And so there is, which brings me now to this particular to do, and we have to add a particular logic here which says we have to check for the result if result contains. So if it does not contains, result dot contains, and then this not symbol here negates the entire condition. So if this returns true, it's going to negate it. So in order for this to be true, this whole condition has to be false. You understand? Yeah. It does not contain, and what we want to pass is a list of this integer. So what we'll do is we'll extract this into its own variable, right? And we're going to say permutation, which is going to be a list of integer, and we're going to say permutation, which shorthand should be toList dot toList of that norms. And so we're going to take the permutation and we're going to put it here, right? And this should essentially solve that problem. Permutation. Oh, so it since we already do the to list there up there, we don't have to pass the to list here. We just have to pass the permutation because we already have the same thing. There we go. So we have a pass. Our two test cases passed successfully. So if we attempt to submit, hopefully that should work. At least that's my approach to this particular problem. So let's see. Yeah, that works. It's not the best solution, it's a terrible solution. Finding all the permutations, then getting just the unique ones. So what happens is we can what can we do? So can we do something? So that's the first approach, but if we made a value the second time, I think I can do something. We can do something to make that better, in such a way that we don't have to find all the permutations. List integer. So we're passing an index. We're passing the index of 0 to require the index. We can we keep like the number of used index really? Let me see. The number of used index. Because I want to check if we have already got into that index side and then skip that. I don't know if that will be possible. So definitely pass in the 0 here, and then pass in 1. Or come here if it repeats itself. If I don't know, we can. I know that. See. Okay, so what I think we should do is, now we already have a solution, so go right ahead and give this video a thumbs up, although it's the dead last of it. But in order to make this better, what I think we can do is, because we are doing the index, right? What I think we can do is we can keep a registry of all the values we use, okay? And in order to do that, let's just say when we use a value, we need to just put it somewhere, and we have to make sure that we cannot add that value twice. And I think if you, the bet we're going to use something like a HashSet, so we can have like a set, I think set of integer, right, which will be used equals to a new hash set, something like that. And what will happen is, just before we do all the stuff, we are going to check if current number at index is used, and which is going to be if used but contains, this is a collection, norms index. We want to just want to skip it, continue, right? And then if that's not the case, if it's not used, then the first thing we want to do is add that to it, used dot add, and then that will be norms index. I hope that is correct. So let's check that. Is it? Oh, is it? I think that thing will be I rather than index. Yeah, be I rather than index. I don't think, since we're already screening for this year, I don't think we need this particular approach anymore, right? Because we're already screening for that. So this makes sure that we don't have duplicates. And I think that will pass, and we're also going to be good to go. So let's see. There we go. That was better. So the difference between the first approach is that we're literally looking for all of the permutations, and this last approach, we are now making sure that we only because the permutations that you're going to get for this one is going to be the same permutations you're going to get for this one. So we're only making sure that we only check for one, and if we get to this particular level, we skip it, right? We get to this level, continue, and that's the idea, and that's what we did here. And so we have a much more efficient algorithm, which is good. So this video is not being short as I thought it would be. I don't know. So if you find this interesting, please give it a thumbs up, like this video, subscribe and share, comment your thoughts and your approach and what you think about the entire series and the entire solution and this video. I'd like to hear from you. Support me by sharing, support me by clicking the like button, and subscribe to the channel. Click the notification bell so that when I upload new content, you can also get it. All right, that's it. Thank you very much for watching and for tuning in, and until next time, have a nice day. Bye.